Hello students, welcome to my YouTube channels. So again I came for another new Lami's theorem problems. So again these problems I will solve with simple method. So just watch this video. What is the questions given? Find the tension of the segment AB, BC and CD. So given AB segment, BC and CD. Given angle here 30 degree, here 120, here 60 degree. This is the given. Weight the given 100 Newton both. Okay. So now. So already I told they will not mention solve by which method. So you have to see this problem and you have to find out how to find the tension of the string or segment. So if you will see here point B, you are able to see here three forces crosses, one AB, one BC, one load. If you will see the point C, again here BC, CD and load. So that means you are able to see the three forces crossing at the point. That means three coplanar forces passing through the one point, that is called concurrent forces. So that means we can apply the Lami's theorem. Other method, if you see like resolution of method, some forces, so that will be complicated to get this all the three segment. So you have to identify, seeing these problems you have to identify where should apply the Lami's theorem. So okay, now Lami's theorem, before applying, what we need? We need the three angles. See, P opposite to forces angle alpha, Q opposite forces beta, and R opposite forces gamma. That only is the Lami's theorem telling now three coplanar and concurrent forces passing through the point. So opposite of the two forces angle will be the proportional of the sine of the particular forces. So this is the relations for the Lami's theorem: P by sine alpha, Q by sine beta, R by sine gamma. That means force opposite angle. So okay, this relation. So if the three angles will find out, we'll apply the Lami's theorem at the particular point. So before this, we'll draw the free body diagram. So look here. I will draw the free body diagram. This is the fixed part. This is the one line. This is the weight. Then this given vertical line here. This should draw the vertical line. Then this line will be little inclined. So inclined line. Then again this line will be there, one weight will be there. Okay, I draw little bigger diagram so it will be visible clear. So the weight the given 1000 Newton. Here also the given weight 1000 Newton. Okay, so this you can, because applying geometry now, so you, okay, here also will draw one line. This given line is there. I am applying the geometry everywhere. Okay, so this line also will draw the vertical line. So draw the vertical line from this. So this angle the given how much? 60 degree. This is point D. This is point, just write this is point C. This is point B. Somewhere we'll write, because angle I have to write now. So somewhere we'll write this point is B. Okay, B. This is point A. See, I will apply the geometry now. Small constructions will do here. Two easy steps we will understand easily. So small constructions will do here. Now this angle is given how much? 120. This angle given how much? 120. This angle they given 30. So this will be 90. So this angle will be 60, I know. 30, this is 90, right angle triangle. So we know. This angle is 90. So this will be 30. This will be 30. So okay. So okay. Now, if we'll join this, okay. Now look here. This angle how much? 90. This angle 90. This how much? 90. Okay. Now this 90, this 30. Next will be 30. So this angle will be 30. This angle will be 30, correct. So this will be 60. How 60? You see here. Suppose this vertical line is there. This vertical line will be there. This will be 180. Then this is 120. Then this angle will be 60. So 60 plus 120, 180. This is 90. This angle will be 30. This angle will be 30. So look here. This 30, 90, 60. This 120. Now this line is 90 degree. So this will be 30. This I know now. Okay, this 30. Now look here. I told this angle is 180. So 30 plus 30, 60. So 120. So this angle will be 120. This will be 90. This will be 90. I think all the angles we know. Now. Now what we'll do now? We'll draw the junction point. So draw the junction point here. At B point you draw here. B point, junction point we draw. B. This line is going this way. This will write TAB. Segment of the string A or tension of the string A. So now B you write somewhere here. Now this line will be TBC. This point is C. So TBC. Now we'll find the angle. So this weight and this TAB, this angle how much? 90 plus 60 is equal to 150. 90 plus 60 is equal to 150. Now TAB and TBC, this angle how much will say? 120 plus 30. 120 plus 30 is equal to 150 coming. Then this angle between this 60. So 150, 360. So total how much? 360. So we got it. TBC. Okay. Now look here. This weight is given how much? 1000 Newton. Now applying the Lami's theorem, at point B. So what is that? TAB is equal to sine 60 degree. Then TBC equal to sine opposite angle 150. Sine 150. Then 1000 divided by sine 150. This I know. So this we know the relations, then we can calculate the value. So 1, 2, 3 relations. Now 2 and 3 will group and we'll get the value. So R 1 and 3, 2 and 3. So we'll get 2 and 3. TBC by sine 150 is equal to 1000 by sine 150. Very simple here calculation. If will this will get cancel. So what will get here? TBC directly will get 1000 Newton. TBC directly will get 1000 Newton. Now next 1 and 3. TAB equal to sine 60. TAB is equal to sine 60, and then you write here 1000 sine 150. So TAB you will get that calculations already with TAB you will get 1732.06. 1732.06 Newton. So you will get this value. TAB. So I know this too. Now apply the Lami's theorem at point C. So draw this diagram. This is the weight, 1000 Newton. Then this is the forces, and another forces will be this. Apply the Lami's theorem at point C. So see this, between C and D, this how much? 90 plus 30, 90 plus 30 equal to 120 degree. This is 120 degree, then 90 plus 30, 120 degree. So all three angles are equal. All three angles are this angle, and this angle. So no. Now we'll write the relation. What is relation? This is TBC. TBC. This is TCD. So write TBC equal to opposite angle sine 120. Then TCD opposite angle sine 120. Then 1000 opposite angle sine 120. So okay. So directly see all denominators will be same. So we can write TBC. Already we know how much, 1000. So only TCD we need. TCD equal to 1000 Newton. Because this 120 will get cancelled. Consider last two. 120 sine 120 will cancel. TCD is equal to directly 1000 Newton. So we know all the value. TBC, TAB, TCD, we got the value. So this way you can calculate the string problem. So what is major things you are seeing here? Once they given, you apply the geometry. See, we apply the geometry. This right angle triangle 30, 60. Then this 60. Then total this angle will be 180. So 120 plus 60, 180. Then this again, this vertical line, this horizontal line, right angle triangle. This I got 60. This 30. Now suppose this 60, this 90, then this is 30, then this angle will be 30. How? Because 60, this is 90, 30, then total this base angle is 180, so 30 plus 30, 60 plus 120, 180. So this way we can get the angle. Once we got the angle, we'll apply the Lami's theorem with the particular junctions, we'll get the answers. Okay, students, watch this full video. All the geometry what I did, that you have to practice. Take the one page, practice this geometry, then only you can solve this video. Okay, after watching the video, subscribe that video, then only you will get the new notifications directly. Okay, thank you, students.